Hello guys, you're welcome to Math Hub. In this video, I'm going to be teaching you how to apply the mirror formula. Okay, this is optics, light in physics. So the first thing to note is that the mirror formula is given by 1 over F is equals to 1 over U plus 1 over V. You can either write it like that or you can choose to write it like this. You're going to get the same answer. In this case, you're going to be looking for LCM most of the time if you are solving the questions. But in this case, you don't need to find any LCM. Just plug in the values and cross multiply. So whichever one is convenient for you, both of them will give you the same answer. Then let's take note of the parameters. The first parameter to take note of is V. So V is called the image distance. That is the distance of the image. Okay. The next one is the object distance, which is U. U is the object distance. How far is the object from the mirror? While the next one is the focal length. The focal length is the distance from the pole to the principal focus. So you have something like this. This is the pole here. This is the focus. And this is the center of curvature. So let's assume the object is at this particular point here. The distance from this point to the mirror is U. That is the object distance. So then depending on where the image is located, then let's assume the image is located at this particular point here. This is the image here. The distance from this point to this particular point of the mirror is V. So U is the image distance, while V is the object distance. Then the focal length is just the distance from the pole, which is center of the mirror here, to the principal focus, F. Okay, so all you have to do is relate everything into this formula, and you can easily find the respective parameter you're looking for, depending on the question. You need to take some note of some other things too. For the focal length, F, if you have a convex mirror, which is a mirror that looks like this, the inside of the mirror is totally painted, so the reflective surface is on the outside here. This is where the reflected rays meet. So for a mirror that is a convex mirror like this, the value of the focal length is always negative, so F is negative. So anytime you say convex mirror, that's not that the focal length will be negative. Then the next one, for a concave mirror, talking about F for a concave mirror, the focal length of a concave mirror is positive. Okay, a concave mirror looks like this. The reflective surface is on the inside of the mirror. Okay, on the inside. This is the outside of the mirror. So this is the reflective surface inside where the rays actually meet. So for a mirror like this, which is the concave mirror or a converging mirror, the focal length is always positive. Then another thing to take note of is U and V. So U is the object distance, V is the image distance. So if the image is virtual, the value for V will be negative. Okay, if the image is real, for a real image, the value for V will be positive. Then for the object, if the object is a real object, it will be a positive value. If it's a virtual object, then the value will be negative. So if you know all this in mind, you don't have any problem. And just remember that magnification, that is how big the image will be, is the same thing as V over U, image distance over object distance. Or you relate it to image height divided by the object height. So anyone you use, you're going to get the same answer. Then lastly, radius of curvature is equals to F times 2. Okay, radius of curvature, which is R, is equals to F times 2. That's the focal length times 2. We give it radius of curvature. So bearing all this in mind, let's take some questions to solidify your understanding of this topic. So an object is placed 20 cm from a concave mirror of focal length 10 cm. The linear magnification of the image produced is dash. So we are given these options to find the magnification for this question. So let's analyze the question and pick out all the basic things that we need to solve this question. So if you check the question very well, you see that the object is placed 20 cm from a concave mirror. That means the object distance U is 20 cm. Okay, then the next thing to check is that we are told that the focal length is 10. So that means F is 10 centimeter. But don't forget that M is equals to V over U. Okay, that's the magnification. So the next thing to do here is just to find V. We need to get V for us to find M. So for you to find V, use the mirror formula. The mirror formula is F is equals to UV all over U plus V. So substitute into this formula, F is 10, UV, that will be 20 times V, divided by 20 plus V. Then we cross multiply to get 10 into 20 plus V is equals to 20V. We expand this bracket, 200 plus 10V equals to 20V. From here, create the like terms. 200 is equals to 20V minus 10V. 200, 10V. Then divide both sides by 10. This will give you V equals to 20 centimeter. But this is not what we're looking for. I try to find the linear magnification. So from here, we can easily get the value of M. M is V over U. So from here, V is 20 cm like we've got in our solution. Then our U is also 20 centimeter. So by the time we cut everything out, you're going to get M is equals to 1. So our answer is M is equals to 1, which is option C. Okay, let's try the next question. A concave mirror positioned at a distance of 5 cm from an object gives the linear magnification of 4. If the image is upright, the radius of curvature of the mirror is dash. So we are given these options to find the radius of curvature. Pick out the parameters from the question. So you can see that the object distance is 5. So U is equals to 5 centimeter. Then the magnification is 4. M is equals to 4. And the same formula for M is V over U. So M is equals to V over U. Then we have to find the radius of curvature of the mirror. That means you need to find the focal length first. Once you gotten the focal length, you times it by 2 to get the radius of curvature. Okay, like I told you guys initially, the radius of curvature is 2 times F. Okay, so we need to find F first. And you can only find F from the mirror formula. That we are told that the image is upright. Okay, the image is upright, and this is a concave mirror. The only time a concave mirror produces an upright image is if the image is virtual. That is, the object is placed between the focus and the pole. So the object is actually around here. So it will produce a virtual image that will be behind the mirror. Okay, that will be behind the mirror. So for a virtual image, the value for V is always negative. It's just taking that V is going to be negative in this case. So let's find the value of V first. Since U is 5 and M is 4, so we're going to get 4 is equals to V over U. But our U is 5. So you're going to say 4 is equals to V over 5. From here, cross multiply, you're going to get V equals to 20 centimeter. But since the image is virtual and it is magnified, V is going to be minus 20 centimeter. Okay, so we're going to plug in this value now into the mirror formula. So the mirror formula is F is equals to UV over U plus V. So let's find F. So F is equals to, so our U is 5. Okay, our U is 5. We're going to write 5 times, our V is minus 20. Then we divide this by 5 plus minus 20. So at the top, you're going to get F is equals to minus 100 divided by 5 plus minus 20 is minus 15. So if you divide this, you're going to get 20 divided by 3, which is 6.67. 6.67. So you have to be careful at this point because this answer is in the question. This answer is in the question. That's option B, but that's not the correct answer because this is just the focal length. So we want to find the radius of curvature. So we need to multiply this answer by 2 because radius of curvature is F times 2. So let's do 6.67, then times it by 2. Times that by 2, we're going to get 13.34. 13.34 centimeter. This is the radius of curvature. And this answer is option D. So the correct answer is option D. Okay, I hope you understand. Let me know in the comment section if you have any issue with any of the sections. For this next question, we are told that an object is placed 6 cm in front of a concave mirror of focal length 9 cm. The image formed is dash. Okay, then give us some options there. So an object is placed 6 cm. So let's pick out the parameters first. So an object is placed 6 cm in front of a concave mirror. The object distance, which is u, is equals to 6 cm. Then the focal length is 9. That's f is 9 cm. So what they want us to do is to find the position of the image. Then from there, maybe we can get the properties of the image formed. So let's find v. So we're going to use the mirror formula. So we're going to use f is equals to uv over u plus v. So 9 cm, let me just say 9 is equals to 6 times v over 6 plus v. That is substituting everything into this formula. So you're going to cross multiply 9 into 6 plus v will give you 6 times v is 6v. Then from here you expand the brackets. 9 times 6 54, 9 times v 9v give you 6v. Collect the like terms. You're going to get 54 is equals to 6v minus 9v, which will give you 54 is equals to minus 3v. From here you can divide both sides by minus 3 and you get v is equals to minus 18 centimeter. So we can see that the image distance is negative, and anytime the image distance is negative, what should come to your mind is a virtual image. So the image is virtual in this case, and a virtual image will always be behind the mirror. Okay, it will be as if it's inside the mirror at the back like this. This is where the image will be, and it will be magnified. Okay, so the answer to this question is v. The image distance is 18 centimeter from the mirror, and the image is virtual. So the answer is option A. For this next question, we are told that the image formed on a screen by a concave mirror of radius 30 centimeter. So r is 30 cm. So this r is the radius of curvature. Okay, it's 3 times the size of the object. So the image is 3 times the size of the object. That means the magnification is 3. Okay, we have to find the distance of the screen from the mirror. So that is, we are told to find the image distance. So as if you have the mirror like this, then there is a screen somewhere here. So you know that the image of this object will be formed on this screen. So we are told to find this distance. This distance is v. Before you can do that, you have to find u first. So from here, from this formula, we can easily substitute for v. So you can see that v is equals to 3u when you cross multiply. So bear in mind that our r is 30 centimeter. You can easily find f. F is always r divided by 2. So when you do your r over 2, you're going to get 15 centimeter. That is the focal length. Then plug all these guys into the mirror formula, which is f is equals to uv over u plus v. So if you do that, we're going to get 15 is equals to, so our u is u times our v will be 3u. Okay, 3u over, then you have u plus v, that is u plus 3u. U plus 3u. Then 15 will give you 3u squared divided by 4u. Cross multiply, that will give you 15 times 4u. From here, 60u is equals to 3u squared. You can divide both sides by u. So cancel out the u. So you are going to get 60 is equals to 3u. From here, you can divide both sides by 3. So you're going to get U is equals to 20. Okay, centimeter. Now, since U equals to 20, and we know that the multiplication is 3, that means our M is V over U is equals to 3. And our U is 20, just like we got just now. So V over 20 is equals to 3. From here, you're going to get V is equals to 3 times 20. So that will give you 60 centimeter. So the image distance of the screen to the mirror is 60 centimeter. So that is option D as the correct answer. So for the next question, we're told that an object is placed 15 centimeter from a convex mirror of radius of curvature 20 centimeter. The image located dash. So we have some options here to find the properties of the image formed. So let's pick out the parameters from the question first. So the object distance U, you can see U is 15 centimeter straight up from the question. So this is a convex mirror, take note of that. So the R we are told in the question is 20 cm. So you need to find F, which is the focal length. Divide the 20 by 2. So 20 over 2, that will give you 10. But since this is a convex mirror, the focal length must be negative. So our F is minus 10 cm. Now we'll put everything into the mirror formula because we need to find V. So the mirror formula is F is equals to UV over U plus V. So let's plug that in. So our F is minus 10. So we're going to get minus 10 is equals to, our U is 15. 15V over 15 plus V. Cross multiply. Minus 10. Then you can expand the bracket. That will give you minus 150. Minus 150 minus 10V is equals to 15V. Minus 150. I'm just taking the like terms. So this will give you 25V on this side. This will give you minus 150 here. So to find the V, divide both sides by 25. So you're going to get V, if you cut everything, you're going to get minus 6 as the answer. So you can see that the image distance is minus 6 centimeters. That means the image is virtual. It's virtual because this is a convex mirror. A convex mirror will always form a virtual image. The image will be behind the mirror. Okay? So the answer to this question is 6 centimeters behind the mirror. A virtual image is always behind the mirror. So the answer is option A. I hope you understand. So for our next question, we are told that a convex mirror produces an image which is 1/4 the size of an object placed in front of it. If the radius of curvature of the mirror is 32 cm, distance between the object and the image is dash. So the first thing to do, pick out the parameters from the question. So this is a convex mirror. Don't forget that F will be negative. So you can see from the question that R is 32. So R is 32. So your F will be 32 over 2. That will be 16. So since it's a convex mirror, F is going to be minus 16. Then the next thing to note is that the multiplication is 1 over 4. So M is 1 over 4. And M is the same thing as V over U. So if you cross multiply like this, you see that your U is equals to 4V. So U is 4V. So from here, you can easily substitute into the mirror formula to find for V. Let's substitute for U. So F is UV over U plus V from the mirror formula. Okay, now if you do that, you're going to get minus 16, which is the value for F. Then UV, our U is 4V. So anywhere you see U, put in 4V. So you give you 4V times, then you have V here, divided by, you have U here, you're going to write 4V plus V. So this will give you minus 16. Then this will give you 4V squared divided by 4V plus V will give you 5V. Okay, so this V can cancel this V. You're going to get a single V here. You're going to get just 4V. So you have minus 16 is equals to 4V over 5. By the time you cross multiply, minus 16 times 5 and give you 4v. You can divide both sides by 4. So from here, v will be equals to, just cut it out, that will give you minus 20. So you can see that the value for the image distance is minus 20. It is negative because this is a convex mirror. It is always behind the mirror. So u is equals to 4v. The next thing to do is to find the object distance. That will give you u is equals to 4 times 20. Since u is 20, what you need is the numerical value of v. You don't need to take the sign when looking for u. So this will give you u equals to 80. Okay. Now we need to find the distance between the object and the image. So this is how you're going to do it. So this is a convex mirror here, like this. Okay, this is a convex mirror. Now, so the object is placed right here. So this distance is the distance of the object to the mirror. The distance was 80. Okay, here to here will give you 80, that is u. But the image is located on the other side. Well, this is a convex mirror. The image is located on this side here. Okay, this is where the image is. So this image is virtual. It is behind the mirror. So from here to here is minus 20. So you need to see, you are told to find the distance between the object and the image. This is the image, this is the object. So the distance between them is 80 plus minus 20, which is 80 minus 20, which will give you 60. Distance between the object and the image is 60 centimeters. So the correct answer is option A. I hope you have gained one or two things from watching this video, and by now you know how to use the mirror formula. Thank you for watching this video up to this point. I really appreciate you. Like and subscribe to this channel. Until I see you guys on the next one, thank you for watching. Take care and goodbye.